there we go, recording. All right, so the plan today is to go over JavaScript interop. And so we will be looking at how you do interop on a basic level and when you don't need to do that. And then we'll look at React and hiccup syntax. And if we have time, then we'll move on to Form 2 and Form 3 reagent forms. So that a reagent being a wrapper for Facebook React.js. I probably shouldn't call it Facebook, just React.js, but Facebook started it, and then they're on the news a lot right now. So, okay, we'll go ahead and begin there. Before we get started, do any of you have anything else at the top of your mind that you'd like to ask about or look at? Okay. All right, then we'll go ahead and move forward here. And I will share. So for this example, I will be going through some of a project that some of you may have seen before. It's the FTTV project. It was actually one of the first ones I ever wrote in Clojure and ClojureScript. It's for a professor who's doing a display of, or a database of references to fairy tales in popular series. So it's a fun thing. It has some data visualization. It has some interop with d3js. Which, if you don't know that library, D3 is a very powerful and low-level data visualization JavaScript library that essentially provides its own language. Like, the way it does things is completely different than you normally work in JavaScript. And so interoping with it in any time, so interopting with it with React is a challenge. So adding the extra layer of Clojure on top of that took a little figuring out. So that's the one that we'll be looking at today. And let me see if I can pull up what the actual site. There we go. So you can pull this up as well. You don't have to right now, but you can if you want to see it at db.fttv, that's fairytale TV, .byu.edu. So I will give that guy a share. And there we go. All right. So the gist of it, as I mentioned, is that you have a database of all these shows, and they hope to add more soon. And the database should feature a live typable filter, which, there we go. So they chose to not make it update as it goes. So originally it did, as you typed, it would update the field, and they decided they wanted a different interaction, so they changed that. But you can see the gist of that there. And then you have the filters, which are live on the left-hand side here, for narrowing things down as you go. Okay. And then on the visualizations, we have the options I mentioned with D3. So the time series, for instance, it reflects the search that you have going on right now on the database. So let me clear that. So it's everything. I'll head back to the time series. Okay. So we've got all of the stuff that they have entered here. And then it's interactive. So this is D3. It says that, hey, I'm going to take your data. I'm going to generate a visualization. In this case, I chose this bar graph. I've added the hover over effect that shows you which things it's talking about. And so you can see those things. And then you can also affect the range here in theory. And you have to type in a real number. Wow, I am just having lots of issues with that. That is not the number I wanted. Okay. Still not the number I wanted, but all right.
Working on my side.
All right. So if I'm saying before the 1930s, there aren't very many. They're in the database. They include, and by the way, so there are issues with the data here. That's a separate matter. So the data can definitely be improved, and eventually I would like to scrape IMDb into it. I think that would be pretty awesome, but that has not happened yet. So anyway, you have these interops right here with d3js making this possible. And then you have other things. So that's the bulk of it. All right. So if you're wondering what those three are, here are more details right here. Okay. So let's talk about Clojure. Let's talk about how these kind of play in Clojure and how we interop at all. So let me give a little screen here. Just a window. Thank you. Yep, that's the one. All right. So to be noted, I do not have a REPL going right now, so I don't have it connected to a browser, so you'll see the changes live. Actually, I don't know why I don't have a REPL going, because that would be handy. So let me start a REPL. All right. So that's going to take a second, but we'll go ahead and get started with that. All right. So first off, we are looking at the basic syntax here of interop. And so it's important to notice that for interop, we have the typical maps and vectors are the structures we use the most that represent the DOM elements. So I think people are mostly familiar with that. Let's go down to where we actually make some DOM down here. Okay. Yes. Thank you for that. I'm going to, there we go. Winner undo takes you back to screen in Emacs. So we're back to the screen we had. But I do have a REPL going now, as you saw. Although it's actually not connected yet because I haven't pointed a browser at this localhost thing. So that'll be a separate matter. All right. Let me pull up my notes here as well. Okay. So first talking the basic interop and when it's necessary. So Yuri or Easton, do either of you have a memory of how you do basic interop? How you call it a JS thing?
JS/.
Yeah. And I can't remember if I do that anywhere here. There we go. Okay. There's a little bit. So JavaScript includes a parseInt a function which serves to take a string like string 2010 and convert it into the number 2010. So here's a case of using that, just JS/ whatever. That's how you use global level JavaScript functions. So things that are included in the JavaScript core library. Something to notice with JavaScript interop is that you need to be careful sometimes, especially when you're giving values to JavaScript from ClojureScript, because ClojureScript is dynamically typed and doesn't usually care very much what kind of a number or whether it's actually a date or whatever. ClojureScript won't bother you too much about that stuff, but JavaScript does care, which is funny because JavaScript is also dynamically typed, but apparently it is more typed than ClojureScript is. And so you get things, for instance, you have places where JavaScript might have a Boolean test. So there's a test of whether something is true or false that the JavaScript wants, and you have to realize that that's different than the if statements or the kind of test that you might use in a ClojureScript program, because in ClojureScript you have that beautifully simple syntax in all of Clojure, where, well, Easton, can you tell us what is the truth table in Clojure?
The truth table, as in like truthiness.
Yeah.
Everything is true except for nil and false.
That's it. That's the whole thing.
Yep.
And so
a lot easier than other languages.
Yeah, JavaScript there's some nice graphics about how bad JavaScript is, because it is confusing not only with what it literally considers true and false, but the difference between double equal signs and triple equal signs and the way it converts strings into other things sometimes. And anyway, it's a mess. But the flip side is that when you need JavaScript to test something is true or false, sometimes it needs a literal Boolean for that. And so you can't just give it something that you know would be true or false in Clojure, but JavaScript might be a little pickier. So that's a gotcha I've encountered several times when doing interop. So when I'm doing JavaScript stuff. All right, so over here we showed the JS/ is how you call JavaScript core things. And so that's pretty easy. Let's see if we've got another case of that one. We do not in this file. Okay. All right, the next operator that we will talk about, this is good for any interop. So if you're on the back end in Java, this works as well as on the front end in JavaScript. The ... macro. So I imagine you guys may not have used this before. So remember that the syntax normally in Clojure is to say, suppose you want to work with an object. Then you say .object so .object refers to the new operator on the object. So you'd say .object constructor arg 1 or whatever, all your constructors would go here. So .object. And so actually that is not entirely, well, that is mostly true. So that is not quite right. So I'll show you the way, oops. Let me head back there. Okay. So that's not quite right. So I hope some of you caught what I'm trying to go for there. Object dot. That's going to be the equivalent of calling the new whatever on it. So in Java or in JavaScript, you're doing the constructors. You're calling the constructors when you do object dot and then whatever args go into that constructor. So this is the constructor syntax. So you never actually type new blah, blah, blah. You'll do object dot that thing. So that's how that guy works.
So that constructor arg1 would be a map?
It's just whatever that object wants to be. So maybe there's no constructor arg1 if it has a constructor that you simply do new. But sometimes when you're creating a new thing, you'll say new and the first value is like blue and then 3 and then 29, whatever. So there's whatever args the constructor wants. Often there's no args here at all.
Okay.
So, but if there are args for the constructor, you'd put them here.
Mm-hmm.
So again, remember that we're shifting back into object-oriented space here, which for those of you who've been doing Clojure long enough, it's been a while since we've dealt with that. But that's how you make a new thing. All right, and then in general, we would have if we want to call a function, a method of that object, you'll use the dot syntax. So let's say here, let's narrow that down to just we're seeing only that. All right. So if we have, suppose it has a, let's make this a better example.
Yeah, do we want to make, I was going to say, do we want to make it a specific object?
All right. So if that shows up, I think it does. Okay, so the idea is we're making a van. Suppose there's a car object type, which isn't real here, but suppose there is. So this is how we make one. So, okay. So now we say maybe it's got typical setters and getters, which are awful things, but they are what they are. Okay, in all right, so you call with a dot here, so that is a method. Remember, the difference between methods and functions is that a function just floats around. It has nothing it's bound to. A method belongs to an object. So in truth, in ClojureScript and in Clojure, we don't deal with methods that often, unless you're doing interop. So we'd say set color, and then you say in the typical syntax, you're going to have what thing that belongs to. So this is Clojure syntax where you have the function first. The next thing, when you're doing interop with especially objects, it's a method. So it's the method that belongs to my van. You could attempt the syntax on something else that doesn't have this method, and you're going to get an error in your browser. But we're going to pretend that cars have a set color thing, and then the next thing you say is what car you're doing it to, and then we can presume that it would have whatever. Exactly. Like that. So that's the dot syntax in any kind of interop. Now in JavaScript, there's one more type of interop, because you remember that dot set color might actually be a field. Maybe my van is like a map, and it has a set color field. And in that case, I want the field, not the function, because it's not a function. It's a field. So in that case, you would say you'd expect it to be something like that, where you have the dash. Now, in truth, it's probably going to be something, hopefully, it's not going to include the word set on a field. So it'd be something like this. And then if you ran this command, you would expect it to give something back like blue. Okay. So once again here, we've got, here's how you do a constructor. You're going to have whatever constructor dot, and usually the idiom is that those constructors start with a capital letter. In both JavaScript and Java, that's normal. It's not enforced, but that's usual. Idiomatic. Then if you do a dot function name, then you say what that method belongs to, which is my object here. And then what args go to that method. They could be any number of args, but we're going to give it just one here. And we're assuming that. And then here we would check, supposing that this is a JavaScript object, which means it looks like a map. It's just a key value pair inside curly braces. This is going to get the color field out of that object map, that JavaScript object. Now there is a trick to if we don't have a set color, but instead you want to do the JavaScript equivalent of field equals that color. There's a set command. And it has a syntax like this. So these two lines then, the a set and the set color, should be the same thing in theory. Because if they don't provide you an actual function to change it, they're just expecting you to use regular JavaScript to change it. then you do the A set.
So what's the difference between that and the set exclamation point when you're doing
Good question.
JavaScript interop?
Yeah, so set exclamation point is not JavaScript at all. That is only ClojureScript or Clojure. And set exclamation point is used to change the value of an atom. And actually, it's a reset, isn't it?
Yes. What's the other? Swap. Swap's the other one.
Swap is the other one. So,
yeah, you're right, reset.
So reset is not the interop at all. So you use reset when you're changing an atom, which is one of the changeable things in Clojure world.
Right, but if I put in, so if I go reset and then I do like get element by ID, it returns an atom, and then you can just put what you wanted to set that field by. If
so,
I remember correctly,
I've not heard of that, and if that is what happens, then that's kind of a magical, probably going to break at some point kind of thing. It's not supposed to happen, because and the reason is because when you get an element by ID, you're getting a JavaScript or a DOM object, not a Clojure thing. Right. So you're never going to get a Clojure atom. You're going to get whatever the JavaScript object is. In fact, if you try to print that in a JavaScript prompt, it's going to just say like hashtag object something or other. And it's not going to be very handy. So reset is used for atoms, and atoms exist in ClojureScript to be a place where you can modify, where you can mutate something in a controlled space. And that is not a JavaScript idea, because JavaScript is mutable by nature, which we tend not to like. Good question, though. So they are kind of similar. In fact, as you'll see, the reset thing, that's easier. You're dealing with Clojure stuff, and the syntax is simpler. You don't have to jump through mental hoops. It's just easier that way if you're doing it that way. All right. All right. So we have this stuff that we just wrote. Okay. So then that takes me to the next bit of interop syntax that I was going to show you here down here below in the actual code. So the attach axes, this is all D3 stuff. So in D3, there are different ways you can attach axes to the side or below your graphic, and those axes need to line up with the data effectively. So maybe you're going by 10s or 20s or percentages or whatever. D3 lets you have all kinds of options. So in this case, let's look at the interop here. So I'm going, this is kind of what you were talking about. So document get element by ID. Basically, d3js wraps that. And so that's basically what it's doing, .select. More or less. So there's a few nuances, but basically that's what it is. And I've got an SVG in the code, or maybe I've created that. We'll look at that below where it's created. But it's got the ID of a timeline on it. So we're going to select it and bind it in the let here to SVG. So if we were to print this, it's going to be some nonsense DOM object in a REPL. Is not going to say much. If we print it on a console log, it'll be more useful because it'll tell us like what's some of the details of this DOM object. But Clojure doesn't know too much about it. It just knows it's a thing I got from the browser. That's all. Okay. Now remember, this is not at all JavaScript here. This is all going to be ClojureScript, because we have an atom called axes where we're storing stuff. And we've got an X inside the atom, so we're getting it out right here. And we're going to call it X-axis so that we can refer to it later. So we're not changing anything here. We're just getting it out of an atom that we made. Same thing with height. Same thing with the Y on the axis. And same thing with the padding. So these are all atoms so that they can be adjusted or changed later. And those changes will be reflected here. So that's what this is about. So we're grabbing them all. We have a JavaScript, we have a ClojureScript function, remove axes, that we call to make sure it's all clear before we get going on our stuff. All right, and now we're going to use some interop right here. So remember, we had our let up above where we had SVG. So now let's go. All right, SVG. So we have SVG here. We refer to it, and we're going to append to it. So at this point, append. This is something that's good to know. So append is a JavaScript thing, not a ClojureScript thing. Append is something that belongs to d3js. It's something given to us by that library. Now, normally, our syntax would be this. Dot append svg g. Okay, these two lines are the same thing. So dot dot is helping us out here. So normally we'd run it like this: dot append svg, because the svg thing, which came from d3js, so it's not necessarily a strict JavaScript or DOM SVG, whatever it gives you. It's what d3js gives you instead. So it has some extra functions on it, extra methods. So we've got an append on it, and we're going to stick a G in there. And if you were to look at the code of that website, you see this is the way that D3JS and SVG graphics work. You've got G elements, just plain old G all over the place. And you mess with those. That's how you make the graphic things in the SVGs. All right. And
does the following thing also use SVG as its second argument?
yes. So that's the beauty of these dot dot macro here. The dot dot macro says, give me an object, and I'll call its dot method on each thing you follow up with. It's kind of like the threading macro, if you've learned the threading macro in Clojure.
Yeah, I was just going to say the difference would be threading macro takes whatever the last one returns, right? Whereas this one will just always do SVG.
Exactly. So it's going to take all these things, and they're all applying to SVG here. They don't care about whatever the last thing did. They care about SVG. Now, the kind of the equivalent in JavaScript is what they sometimes call callback hell, where you've got dot stuff just up the wazoo. So I like this a little better, but it's the same idea. Okay, so we are appending a G to it, and then we're taking that G, and we are going, and so by the way, so what you said is true. This doesn't normally think about the last thing. It starts with the SVG. Well, okay, that's not quite true. So it does. It is the same as callback hell. So it does think about the last thing, because it's like putting a dot on that last thing. So another dot in the middle of the JavaScript. So we do a dot append, and then we do after that a dot, and then we're doing attr. Now this is a d3js function, attr. It belongs to the G, so we stick a G on it. Now this is a little cryptic because this is not normal JavaScript. This is D3. D3, like I said, does its own thing. But the interop here is what we're trying to focus on. So when we do the attr, it's going to put a style class on the G, and the class is going to be axis and axis -- x. These are classes that D3 cares about. And then we put on that. Now it happens that doing attr, because it's made for JavaScript callback hell type syntax, it returns itself. A lot of libraries do that. So then we call transform on it, and transform then sticks the transformation onto it. So if you go back to that web page, you'll notice that the stuff like grows as you look at the page, like it cascades and appears kind of in a nice format. It doesn't just appear fully grown, but the bars grow as you approach. So that's what this is doing. And then we do call. So this is JavaScript here. This is JavaScript call. Actually, I don't know. This might be D3. And you're calling the x-axis function. And so this is taking a little bit. So it happens that, remember, x-axis that we got from up here, x-axis turns out to be a function, a JavaScript function. Well, at that point, it doesn't matter if it's JavaScript or ClojureScript, same thing. A function got stuck here, and we call it down here. So we started out with the SVG. We append G's to it. We give those G's this class, we append these transformations to it, and they are going to be translations that are going to affect how big it is and where on the screen it's at. So this is what gives it a stagger look. So again, D3js is complex. So we're doing a lot of complex stuff here. But the point here is that we're calling JavaScript stuff. And then we do it again and say, okay, that was our x-axis. Now we're going to stick in our y-axis. And we've got our given spacing here. And then we're going to call that. And when we call that D3js thing, it gives us an axis on the data visualization. All right, so we've seen Clojure stuff and atoms. We've seen JavaScript interop, where we're grabbing a Clojure thing, and actually heavy interop here because we're using a JavaScript library, which is really dominating the scene. So we're using interop on that library. We're using that library's methods to do stuff and add stuff, and we call it. And then when we're all done, we get that visualization on the data viz time series screen that we looked at earlier. All right. So the first question was, what's the basic interop syntax? And I showed you this right here, the dot append. And then I showed you the macro here, the dot dots, when you're going to be doing a bunch of these. And so that helps you get a bunch of them in place without having to duplicate the syntax so much. And then we looked at calling the functions, the methods that belong to whatever JavaScript thing we've got, and then calling functions, JavaScript functions, which, by the way, this took me a little while when I first wrote this years ago to decipher, because the JavaScript looks like something like svg dot append I gotta stop hitting that key. I'm not going to write this one out, but you get the idea. And then so this is what it looked like in the original JavaScript. And it took me a long time to figure out, wait a minute, why do I have dots in some places, and then I have dots with like empty parens in this other place, and so on, because JavaScript is really ambiguous this way. So it happens that x-axis was actually a function, not a element of the variables, and so it works in JavaScript like this, and it's a confusing mess.
So do you
Took me a while to
call,
decipher
or can
that.
you just put x-axis in parentheses?
In Clojure, that's the way it worked, right? In JavaScript, it's going to have the parentheses after it.
Right, but you have to put call there. You can't just leave x-axis there, like in the...
Oh, that's a good question. So we do need call because we're dealing with a function that we got from somewhere. So it's not a function that... So yeah, you are correct. I think maybe it was actually like this. Yeah, I do remember that it actually had call in the D3 code.
Okay.
The JavaScript code that I was translating here. So it was kind of a mess, and it really brought home the fact that in JavaScript there's ambiguity between whether it's a field or whether it's a function. So You have to disambiguate that. So, okay. Any questions about what we've done so far?
So D3 is a JavaScript library?
Yes. Yes. It's for data visualizations.
Oh,
So I think it's data-driven design or something. So that's what the 3Ds are for. That's why they call it D3.
you don't okay.
It's old and it's very powerful.
So you can access to that just by JS/D3. Then
Yes. And getting that in, there were a couple of ways of doing that, but yeah. So you see that right up here. That's right. So we have that included somewhere. Let's see where that started out.
Oh, D3.
There it is.
ClojureScript.
So I'm using two things here. So I happen to be using it as a library in our project right here. So CLJS.js is a hand-curated library database of JavaScript libraries that have been wrapped to be useful in ClojureScript. So they're wrapped, they work in ClojureScript with minimal extra stuff. And so in this case, I'm using their D3 to give me a D3 variable, but I'm not using that, I think, because I've also got another place that's just including it as a member of our project. Let's see. Yeah, so I actually have the D3 included in a file called externs that gets included in the project. And so I won't go into how to do that because that's a whole other lesson. But take it, the point here is, like you say, we're just making sure that D3 is available. So, and we aren't getting it because of, we're actually not using this one. We just have like the HTML template says that it has a normal reference to require d3js. And so the regular HTML has that. And as a result, we can get it here. Let's look at that just for a second. I believe this project, so some of our more modern projects don't use HTML files and templates that way, but they actually just use Clojure to generate those. But this one was an early one, and so it didn't do it this way. Let's see. So this is the template into which the single page app is going to operate. And let's see if this is the one that includes the nope, this one does not include it. So anyway, I won't look into that in detail, but there's a place where just in regular HTML code is bringing in the JavaScript library, and that's how we got it to what we referred to earlier. All right. So that's the basic interop syntax, and you really need it only when you are leaning on a JavaScript library. So it's usually cleaner and better to, if you can do it in Clojure, to do it that way, because you get things like native interop with the core functions. So great data navigation through things, through the threading macros, through get in, through all those things you use there, as well as immutable data. Now you can tell already that what we were doing with d3js was using a lot of mutable stuff, because that's the way it works. We're adding axes and we're changing the values of those axes. That's how you use that one. But when possible, it really pays to stay with the immutable data because it makes things much easier to think about. Okay, let's go through this now and look at how we make different levels of React things. Okay. So for the first thing, so you'll notice that on the visualization, maybe you didn't notice this, but there's a place where it includes like the year in like a shaded number at the front of the visualization. That was the watermark. And so that turned out to be you dynamically calculated where we're going to put that, but it's generated by React. And so we calculate our transforms and how we're going to show that, where we're going to show that, and when it's going to turn out to be big enough. So we're not going to bother showing which year goes with the bar if there are 30 bars and they're all pencil thin. But if they're only 4 bars and they're wider, then the size will be enough that we're going to show a text element, and it's going to have a class called year watermark. It's going to have a style, which will be in addition. So this is an inline style, as opposed to anything that applies from the class and the CSS style sheet. And then it's going to have a width as the rectangle width. So it's going to create this data structure here. And what's gonna be inside the object? So we're going to have a curly brace, HTML, curly brace text, and then it's going to have inside class equals your watermark, style equals, blah, 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 width equals, blah, 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 and then close bracket. Then it's going to have the number. So the year count is whichever number we're at, or the number of things we have. So maybe we have, I think this one might line up with, we've got 20 things in this year. So there's a 20 going to show up inside here. And then, because this is the syntax we're using, hiccup style syntax, then it's automatically going to insert the bracket / text to close the item. So that's what we're going to get out of this. Okay, so that's a normal thing, a normal form 1 reagent React object. So we just return a data structure. It includes a vector, and then it has a keyword. That's going to be the DOM name. Then it has a map. Those are all the args. Then it has whatever goes inside that thing, and then it closes it all. And that's where the HTML comes from. And we should probably take a brief look here at the actual thing again, so we can see what we're talking about. All right. All right, so here is what we're talking about. So I mentioned the watermark. There's that number 3 right there. So there's enough space on the screen to show it. So we show this big old shaded thing. And now let's see if we can't inspect that. All right, so we've got so you see, we talked about the G's and the things that D3 is making earlier. So they are all these things here. We got the G's, but then we have the watermark. And this is the code we just looked at. So you can see it's text. Here's the, wow. Okay. Lost myself. Here's the text. Here's the style that we applied inline. Here's the transform. And again, this is generally in web development, it's good to avoid inline styles. There are some people who disagree with me on web application development, but I still hold to that. The only time you need inline styles is when you have inline changes that need to be calculated, such as exactly what is our scale, how wide are we going to be, and what is our translation supposed to be. You're not going to hard code this into a style sheet, 480 pixels, 300 pixels, negative 300 pixels. That has to be calculated based on other things like how many bars do we have and so on. So that is exactly what we just got out of our code in our ClojureScript that we looked at. So we generated this text element right here, and you barely see it right here, but there's the number 3 that's showing up. That was the count thing that we added at the end. And then the closing brackets are just part of the hiccup syntax because we are within square brackets. So any questions about that syntax, how that works? All right. So let's hop back to the code then and see if we can look at the last bit of the level 3 reagent forms. I can't remember if I have any level 2s in this file, but we can look. All right. So these are form 1s. I say level, but they're form numbers. So this is a form 1 class because it's returning just a vector. It's returning just an object that's going to go to the screen. That's all. Now there's a lot of state here because we got all this. This stuff is a little bit different. So we make a lot of state. We have a massive let statement. And we then do a bunch of do's. So we're changing atoms. So values that will change throughout so this is like a JavaScript constant. So we're changing values that are available at the top level. All right, and then we create some fairly complex stuff that ultimately concludes in our watermark. And then we stick this into our SVG. And because this is React, remember this is React, so we change the SVG and it changes what's on the screen because that's the way React works. That's the reagent part. Okay, there's a type 3. Okay, so I don't have an example of a type 2 here. A type 2 is when instead of returning a data structure, your reagent function, your function returns a function that returns a data structure. And the reason you do that is because you might need closures so that you can pass some variables down that you don't want to get changed. So normally, as you may know already from reagent stuff, you'll type it. You might create something and say, hey, this is an input where you type stuff. And then you start trying to type and nothing happens. That's because when it changes, it causes React to re-render the thing. And so when it re-renders it, it wipes out your changes. So the effect is, hey, nothing's happening when I'm typing. So that's when you use a type 2. So you're making a closure saying, here's some variables that are outside of that re-render loop. So as that thing re-renders and changes, my variables don't get reset. That's a type 2. And I don't have an example of that here, but sometimes that's exactly what you need. And so that's when you use the type 2. Type 3 is more rare, but it's what we see here with this time series thing. So type 3 is where we are interacting directly with the React lifecycle. So here we say the marker, first off, is that we're using the RMS reagent. So reagent is our wrapper around React, and it has a function create class. So we're using its create class, and that's kind of what marks it as a type 3, a form 3. And then we are telling it what to do at each of the lifecycle events, or several of the lifecycle events in React. One of the lifecycle events is component did mount. So after React has rendered it to the screen, rendered the actual item to the screen, what do? We attach the axes. Now, we need those axes to change as I'm doing the filters. Remember I might change the number of results or something, and those axes need to change to compensate the new values. So I've also got a when component did update, do the axes again, attach the axes again because the axes are different now. So I'm reacting with the React lifecycle here. Display name, I believe that's used in the console logs and the log statements, so that's not important. And then finally, Reagent Render is the ClojureScript part of this that says, okay, what is this actual thing going to be? Like, I created the first time. Before we do anything else, what is it actually? And it's a function that ultimately returns the data structure. Remember that in Clojure functions, there's no return statement. They just always return the last thing in them. So it operates a function first. So it does this thing that is going to update the teleography according to the filters or whatever. So if I said only show me adventures, this is going to make sure that happens. So that is not related to the visualization, but it needs to be in line here. So then we forget that it's not part of the return. It's a side effect. And then here's the return. A div.timeSeries with an H1 at the top. That's time series. Now, this is not visualization yet. This is the static stuff. But then we do mount tooltip. This is where we're sticking that thing on. So when I hover over it with my mouse, it follows my cursor around and shows me what I'm over. We didn't go into the details of that, but that gets mounted here. And then we generate the actual visualization here. And the point is that this is inside the React lifecycle. So we have component did mount. And when it updates, it's going to attach the axes again. And then here's the base thing is going to be. So every update is going to refire the rendering here. Actually, that may not be true. It may just do the component did update. But it's going to do this. And this is the part, this is React, so it's responsive to atoms. So as you change values that are in an atom that this depends on, the right parts of this get re-rendered. And that is why ClojureScript is very good at doing React, because it can do all of that almost under the covers, almost behind the scenes. So there we have a Form 3 reagent item that is part of what we get with our visualizations here. All right, there we go for interop. Any questions before we split? All right, Madeline, I think that this is the newest to you, so there's probably like a fire hose effect. There's the whole lot we just talked about. Is there any particular thing that is the most unclear so far? That was, I know it wasn't very clear.
I guess like the different types that we were just talking about. Like, I feel like I understood pretty much everything up to that point.
So when you say types, what do you mean by that?
Yeah, when you're talking about like type 1, type 2, type 3.
Oh, okay, yeah. So I should have called those the technical term. These are terms within the Clojure reagent library. And
okay, which is the wrapper for React.
Yes.
Okay. Yeah.
Let me see if I can find, and I can share this later, the place where this is at.
Okay, yeah, that would be good.
But let's see. Maybe I've got it linked here. Let's see. Nope, I don't think I do. Oh, maybe I do. No, I don't think so. So Reagent provides a number of things that usually you don't need to know about, but it does have different forms that we mentioned. So these are its terms, not like JavaScript or React terms.
Okay, yeah.
And in summary, they were Form 1 is what you use the vast majority of the time. It's like what I have on the screen right here, where actually that's the type 2. Yeah, so here's a Form 1. All it does is return a vector. The vector may have some more stuff in it, but that's all it is. That's a Form 1. You use that the vast majority of the time. Form 2s return a function like this. They return a function that returns a vector. And in this case, it's because it wants its atom to be defined outside of that function. So whenever the function redraws, it doesn't restart the atom. The atom is external to the function. That's the type 2. And then I showed you the type 3 a moment ago. I don't think they show it here because they're kind of scary. They actually interact with the actual React lifecycle when on the rare cases you need that, which is usually when using interop. heavily.
Mhm.
So
Would you only use the type 2 like when you have something you don't want refreshed or like?
yeah, that's pretty much that's the only time you use it, and that happens fairly often. There are times where that's what you need.
Yeah.
Yep.
Okay.
Yep.
Okay. I think
So-
I'm pretty good other than that.
Okay. Excellent. Excellent. All right then. Any other questions from Yuri or Easton?
I think
good
I'm
here.
still a little fuzzy on type 3, but I don't think I have too much on that one.
Yeah, I mean, type 3, you really need to know a little bit more about how React works
Yeah.
for that to make sense.
Yeah.
That's where you're saying, hey, I need to control the way my thing is going to update and when it's going to update. That's when you need to type 3. The other thing about type 3 is when you're using JavaScript that needs to know about itself. So you need to, like, maybe the JavaScript would say self dot blah blah blah, and usually you don't have self dot whatever in ClojureScript. But where you're saying, I'm going to create a thing and it's going to have an ID, and then I need to do something to that thing with that ID. Usually you need to type 3 to be able to get that. Otherwise, you can get kind of tripped up on you can find yourself in race conditions where, oh, it hasn't rendered yet, or it doesn't exist yet, or I'm writing the code here and the code says, hey, grab this thing, but React hasn't actually made that thing yet, and so you get issues. That's when you need to type 3. Does that make sense?
Right.
Okay. All right. Thank you, everyone. Thank you for everything each of you have done.
Thank you.
Thanks.